Hey guys, this will be a video for the 3.3 3.4 homework. I'm kind of late in getting this up, but here we go. So let f and g be inverse functions that are differentiable for all x. If f of 3 is equal to negative 2 and g prime of negative 2 is equal to negative 4, which of the following statements must be false? So I'll be honest. It is very hard to keep track of what's going on between functions and their inverses, but that's why I really like to use, I am going to explain the way that I look at this by kind of just like trying to graph what I'm thinking about the problem. So whenever I'm thinking about inverse functions, I always think about the point at where we're looking at. There's two different points we have to consider. There's going to be a point on the function f, there's going to be a point on the function g. We need to know the point of both of these, we need to know both these points and the derivatives at both of these points in order to complete the whole picture. So I'm given the point 3, negative 2 of f. So 1, 2, 3, 1, 2. So I know that the graph of f, I'll do this in blue. I'm going to do anything regarding g in green. But the graph of f has the point at 3, negative 2. I don't know its slope right now, but I can get its slope pretty easily. But before I get its slope, g is going to have the point negative 2, 3. And I know that because f and g are inverses. So if f has a point at 3, negative 2, g is going to have a point at negative 2, 3. So again, this is just what I'm thinking in my head, what's happening. So I'm going to go negative 2 and then up 3. So g is going to have a point right here. Remember that inverses are going to have are reflections of each other across the line y equals x, and that's why you can just switch their points like that. Now I know that the graph of g has a slope. At this point, the instantaneous rate of change is negative 4. So if there were a tangent line at this point, the tangent line might look something like that. So this is like kind of what I'm thinking. That's a slope of negative 4, maybe roughly about. Okay. And then today we learned that the inverses at the points where they're being reflected about, so these points right here are going to have reciprocal slopes. And so if this graph right here has a slope of negative 4, then f is going to have the slope here at negative 1/4. Negative 1/4. Whoops, I kind of drew the positive slope there. So no, I didn't. So if there were a slope of this line right here, if we were to maybe put a tangent line around that point, it would look maybe something like that. Their slopes would be the reciprocal of each other. And so there you go. I know that option number 2, this one has to be true. So at 3, the graph of f has to have a slope of negative 1/4, because I know that the graph of g at x equals negative 2, where you switch the inputs and the outputs, this is going to have a slope of negative 4. Now, what about these other two options? So the other options has to basically be consistent with what a function is, or how you define a function. A function cannot be, a function has to be one-to-one. It can only have one output for every input. So if we say here, if we take for example the derivative at 0, so I don't know where, so somewhere along this line, say that the graph of f has a point, it doesn't really matter where, but if the slope is 1/4, that would mean it would be positive. So let's say that it had a point up here, and let's say that the slope is 1/4. So if this has a positive slope here, and over here it has a negative slope, then at some point in between here, we have to change the graph of f would have to change from being increasing to decreasing. And if that's the case, that means this function right here would not pass the horizontal line test. That means f would not pass the horizontal line test, which would mean that the inverse of f, which is g, is not a function. And so in that case right here, this must be false right here. This one has to be false because, again, if the graph of f changes from increasing to decreasing, in class we went over a term, we called it monotonic. A monotonic function, always decreasing or increasing, one or the other, but not both. So if a function has positive slope somewhere and negative slope somewhere, that means it is not monotonic. And that means, and then non-monotonic functions, their inverses are not functions. Okay, so this has to be false. Now, let's say the derivative at 5. So if I go over to x equals 5, and it's saying that the slope is -1/4, well, that would be okay. It would mean that it could be true. We don't know for sure. It could be true, but we don't know. It could be true. Could be false, but this is just saying which of the following statements must be false. Definitely option number 1 and option number 1 only. So there you go. Okay. For 2, look at what it says right here. A decreasing function g. So decreasing function, that's saying that g is monotonic. G of 4 is equal to 6 and g prime of 4 is equal to -2. Which of the following statements about the inverse of g must be true? Okay, so I'm going to assume that they're trying to get us to, they're looking at what the slope of g is. So again, if g has the point 4, 6, then g inverse of x is going to have the point 6, 4. So I can say this right here, g inverse of 6, not prime, g inverse of 6 has to be equal to 4. Now, what would have to be the derivative at 6 of the inverse? That would have to be equal to, well, I know that the derivative at x equals 4 of g is equal to -2, so that means this derivative at x equals 6 has to be equal to the reciprocal of that, so this would have to be equal to -1/2. And yeah, that should be it right there. Okay, so that would be D. As for the other ones, this one has to be true. It definitely cannot be this one right here. Can't be this one right here. And we don't know what's happening at -2. So not super helpful. Okay. All right. Let's try 3. So 3 is going to be, I believe it's going to be very similar to what we did in 1. Very, very similar. And so now that we have a kind of an understanding of what's going on there, I think we should be able to walk through this without really having to graph. But again, so the graph of g, is going to have I don't know if that is really useful. Maybe it is. So the graph of g is going to be at the point 7. It's going to have a point 7, -5. And I know that the slope at this point right here is 3. Now, f prime of -5 is going to be... Excuse me, sorry guys. The slope of f is going to have the reciprocal of the slope of g at 7. So this is going to be 1/3. So I know that this has to be true. Okay. Now I know that this one has to be false because I can look at the derivative, and we're saying that the derivative at 3 is negative, but at -5 it's a third. So the derivative is changing from being increasing to being decreasing, which in that case right there, if that were the case, that would mean that g would not be a function. And so this one would have to be false. And then at 7, they're saying that it's 1/3. That could be true, but we don't know for sure. So again, it's just going to be 1. That's the only one that has to be false. Okay. 4 is going to be very similar to 2. Very, very similar. And so let's see here. So I know that f of 10 is equal to 5. I know that f prime of 10 is equal to 8. Which of the following must be true about its inverse? So I know that the inverse function at 5 is going to be equal to 10. Not that this part matters, but I do know that at x equals 5, so the derivative of the inverse at 5 has to be equal to the reciprocal of this right here. That's going to be equal to 1/8. So that's going to be D right there. Okay. For 5, so for 5 right here, we're given that f of x is equal to arc sine of x, and we're finding the limit as x approaches 1/2. This just means right here, that means f prime of 1/2. So we need to find the derivative of f. Well, that's given to us here. So we're going to say f prime of x is going to be equal to, well, the derivative of arc sine is 1 over the square root of 1 minus x squared. I think that's right. And then we want to find f prime of 1/2. So f prime of 1/2 is going to be equal to 1 over the square root of 1 minus 1/2 squared. Okay, that's going to be equal to 1 over the square root of 1 minus 1/4. That's equal to 1 over the square root of 3/4. And that's going to be equal to 1 over the square root of 3 over 2, which is equal to 2 over root 3. And if I look at my available options here, it's got to be C. And would you look at that? The answer is given, and it's not, the denominator is not being rationalized. So everything you learned in algebra last year was a lie, pretty much. No, just kidding, but kind of, but yeah. All right, cool. That one's not bad. All right, 6. I really hope you guys watch this video on 6 because I know that everyone's going to have questions on this, because I have questions on this, because we'll go through it, but it's really not a fun question because the way that they simplify it is kind of just like, why? So we'll go through it. All right, so cosecant. Derivative of cosecant, if you need the shortcut, is -1 over the absolute value of x times by the square root of x squared minus 1. Now, we're not using x in this case, we're using e to the x. So that's what's going to be in place of that right there. And then we're also going to have to multiply by the derivative of e to the x, which is going to be e to the x. So I know my derivative. I'm going to erase that right there. Don't need it. The derivative is going to be equal to negative e to the x, because that's the derivative of the inside. It's going to be equal to negative e to the x over the absolute value of e to the x times by the square root of e to the x squared minus 1. So there's the derivative, but you can look at your options here and you're like, none of those options are really here. Now, I think I can confidently say it's not going to be A or B. It's got to be C or D. It's definitely looking like D. Now, how do I get from this to that? To be honest, I'm not even sure if I can get to it algebraically. Something's just weird about it, but I'll give it my best shot. let's see what we can do. Well, one thing that I know is that I don't need the absolute value signs because e to the x is always positive. So those don't matter. E to the x and e to the x, those can cancel. So that's going to be equal to -1 over the square root of e to the 2x minus 1. Okay. Now, how am I going to get from here to here? So this is where I'm like, why would you do this? But I think that's how they get there. It also might be how they're taking the derivative. They might be taking the derivative of this more from like how you do the proof to get the derivative, how you get like the shortcut. They might be doing it in that way, which so they're not doing it in the way of the shortcut. The shortcut would, this right here would be perfectly fine. But that's just what I'm thinking. And so that's why our derivatives aren't matching up right away. And so just trying to algebraically manipulate this to get one of these right here, that's the problem that we're running into. But I think what they're doing, e to the 2x over 1 minus 1 over 1. So I think what they're doing, I think what they're doing is taking the terms here, and I think they're dividing by e to the 2x or something. Because you notice here how it's 1 right here. So how am I going to get 1 if e to the 2x, if that's the first term here? So if I divide this by e to the 2x, I'd also have to divide that by e to the 2x, which is how you get that right there, if that makes sense. So if I divide... this is so weird. Divide this by e to the 2x. So divide by e to the 2x. Divide this by e to the 2x. I still don't think how that's going to understand. I don't understand how that's going to get d. That's going to be equal to -1 over the square root of 1 minus 1 over e to the 2x. I don't think I'm doing this property correctly right here. In some way, I feel like I need to review this right here. In some way, I'm going to have to take the square root of e to the 2x minus 1. Yeah, this one's tricky. I don't know how they're getting that algebraically because that is just weird. I might have to go look at the explanation in the AP website. They usually have explanations to these problems right here. But they're getting this right here, and I might just have to come back to this, or maybe in class we'll have to talk about it because it's just weird. But I want to finish the assignment so you guys aren't waiting on me. So let me just finish these other two problems, and then if you guys want to stick around, maybe then I can finish 6. So for 7 anyways. So for 7, we're going to do this one similar to what we did up here in 5. So we're going to take this right here, this means f prime of square root of 3. And f of x is equal to arctangent. So I know f prime of x is equal to 1 over 1 plus x squared. And we want f prime of root 3. That's going to be 1 over 1 plus Now, root 3 squared is going to be 3, so this is going to be equal to 1/4. There we go. Okay, and then for 8, take the derivative, the inverse tangent of 3x. So again, I just have the shortcut written up here. This is going to be equal to, now this is going to be multiplied by the derivative of the inside, which is going to be 3. So 3 over 1 plus 3x squared. And yep, there you go. That's got to be D. Okay, so now that that's done, now if you guys care to stick around, I don't know how much longer I'm going to try and work on this, but there is some algebraic property that I'm probably using incorrectly. But yeah, trying to figure out here how am I getting this on the inside, that on the outside. That's the thing that I am not understanding how they're getting there. So because can I just like willy-nilly divide what's inside here by e to the 2x, but like I did before, whenever I did that, I still didn't even get this right here. That's what it looked like that they were doing, but I'm getting 1 right here. I'm getting 1 over e to the 2x right here, and then I'm getting e to the x on the outside. So the only thing I'm thinking, how do I get e to the 2x on the outside, or e to the x on the outside? So the way I'm thinking how they get that, but I'm missing the step in my thinking on how they get that. So if I have the expression like what I have in the numerator, so if I had negative 1 over the square root of e to the 2x minus 1, and all of this right here was divided by e to the 2x, because if I had this right here, no man, that's not working. Because then this right here, the square root of e to the 2x is e to the x. So the square root of this right here is e to the x. So if this were my expression, but that would leave me with 1 over e to the x and not e to the x right there. So I'm kind of hitting a wall on how to simplify this expression right here. So I think I might just stop, go read the explanation that's in the on the website in the AP College Board, because I don't know how much more I can just kind of spitball here. But I do know that the answer is D. And I do know that on a free response question, this is totally fine. Now, again, multiple choice question, I don't know the likelihood that you would ever see something like this. I don't think you would. But yeah. So, really not sure where we're going right here. But I'll just say ... some algebra. Yeah, some algebra. We're going to get negative 1 over e to the x square root of 1 minus 1 over e to the 2x. And I'm sure I'm going to get a lot of people looking at the key being like, what the heck? So, and that's totally valid. Alright, but I'm going to stop there, and hopefully the rest of the video was helpful.